Okay, ITS128. Today is September 8th, Tuesday, and let me share my screen. So here we are. So we're going to start Chapter 3 today. Okay, and as I was going through Chapter 3, we have to spend more than 1 week on Chapter 3. Okay, we got to spend at least 2 weeks on Chapter 3. Four class periods on Chapter 3. It's too important. They cram everything in there, and there's a whole bunch of features. There's a whole bunch of things that Python can do that aren't in other languages that are important for us to cover because it's a lot of what gives Python the power, the added power that and why it's a popular language today. And branching is just not that big a deal. There's a lot of branching exercises and so on, but and loops, and so I think we're going to spend more time on types. In fact, we might even spend more than 2 weeks on types because dictionaries are important, sets are important. Anyway, so I'd like to start with that today. So let's start to let's see. Let's go back to here, and the feedback that I've been getting from a lot of you folks is of you're stuck on the challenge activities. And so if you have particular challenge activities that you'd like me to cover that I haven't covered, why don't you email those to me or put them up in the chat. And based on that feedback, I'm going to try to hit all the challenge activities from now on, starting with Chapter 3 here. I'm going to try to hit them all. And so same with the programming exercises. The participation activities are really you should spend the time to go through them because it does enlighten you, and they're good because they stress the important points um, for for you to be able to do the challenge activity that is coming right up. So if we look at Chapter 3, we're going to learn about all the different kinds of ways that Python stores data. And there's types. There's Python stores data in a variable or a container or something that's called something like that. But then there's different types. There's numbers. There's numbers that have decimal points, and there's strings of characters, and so on. And then there's also sets and dictionaries, and we'll get into all that. Okay, so we start out by talking about strings, and so uh, a string is there. A string is a sequence of characters. It's an ordered sequence of characters. It's like a name or something. There's a definite order to it. It can vary in length, and so here, for example, type a string below to see how a string is a sequence of characters ordered by position. The numbers on top indicate the character's index. Yeah. All right. Okay. Let's run this. What is this? Yeah, this is kind of dumb. Okay. So strings. What are strings? Well, how do you indicate strings? String literals. That's an actual value. It's like a number. It's not a variable. It's an actual value itself. So you indicate strings by surrounding them in quotes, and they have to be consistent. So this is a string. This is a string. This is not a string. This is a number. This is a string because it's even though it's digits, it's surrounded by these little quote things, which makes it a string. This is a string it's surrounded by double quotes, and this is a string also. and which creates a string variable with the value Daniel. Okay, so it's an assignment statement that assigns this variable first name to a value, and that value is the string of Daniel. And so that would be this one here, obviously. And then how do you print it out? Well, you'd print it out this way here, because this here you're printing out of the variable Daniel and whatever, I mean, for the variable first name, whatever that contains. This here is just going to print out the variable name. It's just going to print out FIRST underscore NAME. That's probably not what you want. Same with this one. So this is the correct answer there, and so on. You can go through that. Uh, there's a function called len, which will give you the length of the string. So here, for example, this len, this is a variable, and the variable was set equal to this. All these long things. This is how you use you can assign a a string that's too long to fit on one line. This is how you write that backslash there. So this function here will give you will return the integer value, the number of characters in the variable. So this one has 185 characters, as you can see. This one 26, and this one has only 3 characters. So what's the length of Santa? 1, 2, 3, 4, 5. All right. Where's the challenge activity? Let's do a challenge activity. Challenge activity. Type 2 statements. The first statement reads the user input it reads the user input into person name, which is the variable. The second reads the user input into this person age thing, and use the int function to convert the age into an integer, because really when you're typing the person's name, 39, it's a character 3 followed by a character 9, and really you want to convert that 3 followed by 9 into the integer value 39, so you can add 5 to it. And so it's just simply person name equals, and this can just be can input a string. Oops, input. So we're just inputting a string. That's fine. Person age, however, is got to be converted to an integer, and then we can input it. So the way this function thing works is this is executed, which asks the user to type something in and waits for the user to type something in. And then once you hit the enter key, what you entered in is typed in, then this thing is going to convert it to an integer, that string of characters. Presumably it works. It's possible that causes an error because the person types in something that can't be converted into an integer. And then this thing executes. So if we run it, that's the answer. It tests with Amy and 4, and it tests with Jim and 12. Okay, here's another one. We're supposed to write 2 statements to read in the values for my city and my state. This is confusing. Assign log entry with current time, my city, and my state. Values should be separated by space. So in other words, you're going to have current time here, and that's going to print out, it looks like that. And then you're going to have a space, and then you're going to have whatever the guy entered in for my city. And then you're going to have another space, and then you're going to have whatever the guy entered in for my state. You ask the user to enter these in, although you don't provide a prompt. So anyway, so we just type that in here, and we're going to ask my city is equal to, it's just going to be input, and my state is also just going to be an input. And then we're going to want to do log entry is equal to my, it's going to be equal to current time plus a space plus my city plus a space plus my state. And that's it. So it prints out, looks good. Okay, what's next? Okay, are there any challenge activities here? Let's go find one. Okay, here's one. Okay, so yeah, there's a lot of terms here that we're going to have to learn. Tuples and list basics. Okay, creating a list. Let me go back one. I want to just string basics. So this is strings. Okay, these are just strings. It's a character type. Literals. Okay. Okay, now with lists, we have you start out with a container, something that you call a container, and container is a construct used to group related values together and contains references to subjects other instead of data. A list is a container that's by created by surrounding a sequence of variables or literals with brackets. Uh, okay, so anyway, this is a variable called. It's a variable. It's the name of the variable is my list, and it's actually a list. And this is how you describe it. And so it's a list here. It contains two items. The first one is an integer number, and the second one is a string. And each one of these is called an element. So this thing is a list, and it's got elements in it, and and the elements have an order. And a list is also a sequence, which means it has an order. And so that means if it has an order, that means that each element, excuse me, my lunch. I had corn on the cob for lunch. Each element has an index. So this is index 0 and index 1. So sequence, so on. And the reason I'm pointing this out is because there's other kinds of things that don't have an order. Sets don't have an order. So there's no such thing as an index for sets. All right. So a list. Okay. So and this would be an empty list. That's how you say it. That's how you specify it. That's how you start it out. Then you can add stuff to a list. You can take stuff out of a list and so on. So if you have a list and you define it like this, the print statement works like this. It just prints this out. It prints out the list in this format. Oops. All right. Write a statement that creates a list called mynums containing these elements. Mynums equals 5, 10, 20. Nice. All right. Accessing list elements using an indexing expression. Okay. So here we have a list. It's called prices, and it's a list of three um, integers. See, these are variables. There aren't quotes around them, so these are actually variable names. This variable is this variable. This one is this, and this one is this. And so these variables have values. So this is actually 3.9 million. So this is actually 3.9 million right there, and this is actually 2.4 million, and this is actually 1.85 million. And so here we're printing out these things here, and look, we're here we're okay. So this is a Lamborghini, and here we're actually referring to that value using the name of the list and the index. Lamborghini is the first one, Bugatti is the second one, and the Aston Martin is the third one. So this is just simply a thing that demonstrates sort of how all these things work. And so when these print out, this is how they print out. This thing prints out with the colon because of this. And price is 0 is actually whatever this is, because this is the 0th index. This is the 1 and this is the 2. Price is 0 is actually this. And what is this? Well, the value of that is this. So that's why that 3.9 million prints out there. So anyway, that's how that works. Initialize a list short names with these strings, and this is the sample of, okay. So we can just go like this. Short names equals, I'm going to take this, copy this, copy, and I'm going to go right here and I'll go bracket, Control V to paste, and end bracket, and I'm just going to take out this and here, and let's see if that works. Yeah, it did. Gus, Bob, Zoe. Gus, Bob, Zoe, Gus. Okay, very good. So that was another challenge activity. Updating list elements. Okay, so various ways you can update list elements. So here we're just going to say that the first indexed it by 1. The first element, not the 0th element, the first element of my nums, I want that value to be minus 28. So this is all you have to do, and this 12 turns into a 28. See, so then, yeah, this my nums displays out this whole thing. All right, write a statement that assigns my var to the third element of my list. My var equals my list. Well, what do they mean by third element? Do they mean a 2? They probably mean 2. Yeah. The first element of a list is index 0. All right. Write a statement that assigns the second element of my towns to Detroit. Detroit. My towns to second element, I guess they mean 1 then, equals Detroit. Yep. Trying to be tricky. They're just trying to trick you. All right. Write a statement that performs that. Assume the list is this, and update the price of the second item in house prices to this. Okay, so I'm just going to copy this. Copy. And I'm going to say house prices bracket 1 end bracket equals paste. All right, very good. Add a price to the end of the list with a value of that. To the end of the list? How do I do that? How do I do that? Append. Append. I'm going to use append. List append value. Okay. So I'm going to say house prices dot append parentheses quote $sign 1 comma 000 comma 000 quote close parentheses. Ah, yes, very good. Remove the first element. Do I just say pop or do I have to say pop? Oh, I should have gone through these. Okay. Append. Oh, I see that as that on. Pop 1 removes this one. So I just do pop 0, I guess. Pop 0 will probably do it. House prices. I'm going to just say pop 0. Oh, no, I'm just going to say pop first and see what happens. I'm just going to do that and see what happens. I got to put a 0 there. All right. Remove this using that. Okay. Is it in there? Is it in there? 140. There it is, the first one. Using the remove, there you actually say what you're removing, don't you? So I'm going to say and I'm going to take this, copy it, put it here, and I got to take all this out, delete, and put a period. All right, very good. Okay, are there any more questions? All right, let's see. All right, what this does shows you some nice functions here that you can do with lists, these built-in functions. So here we got a bunch of midterm scores, a list of midterm scores, and here's a list of final scores. And then here we are, what did I? Load default template here. Yes. Oh, did it work? Oh, haha. Okay, so try enhancing the program so it calculates average and average midterm and average final. Got it. Okay. Um, oh, okay. Is there a function called average? No. There's a function called list, and there's a function called, sum, and there's a function called len. Sum and len. Let's see. So I can go average. just go down here and do it. How do they want us to print this out? Okay, well, anyway, I'll just um, I'll just say um, average final, no, average final equals the final scores sum. What is that one? Sum. That's just all I do. It's a function like that. Okay. Sum divided by len. And average midterm is the same. Midterm midterm and print. Might as well do a new line. Average midterm score was AVG underscore midterm. And average final score was AVG final. I wonder if this will work. Forgot. I'll need that. Print's not defined. I don't mean print. I mean print. Right. Now, we learned how to format this, didn't we? Was that in the last chapter? I think that was. Well, anyway, I'm not going to bother doing that, but really, this should be formatted. Let me. Well, anyway, I'll leave that for you. Okay, so and so let's do a. Oh, here we're talking about tuples now. Okay, so these are lists. By the way, is this right? Yeah, that's probably right. Okay, so tuples are different. Tuples or tuples are behave similar, except for this. They behave similar to a list, except for they are immutable. Immutable means they cannot mutate. Uh, a list can be mutated. It can change. You can add to a list. You can change elements in the list. You can basically mutilate it. But tuples, once you define them, that's what they are. Okay, so that's one thing. A tuple is also a sequence type. Okay, it's a sequence, and it's got indexing. And the way you create a new tuple is you don't use braces. You use curved. You use parentheses. You don't use square braces. No, square brackets. Braces are the curly ones. Brackets are the square ones, and parentheses are the round ones. So, for example, long, latitude, longitudes would be like a tuple. White House coordinates. Okay, so create a new variable called point that is a tuple containing this thing and this string, this thing. So you're just defining point equals and then parentheses that, except for we don't want that, there we want a comma. So it looks like that. If the value of this is a tuple containing this, what is the result of this? It's 3. Because there's 3 of them in there. Initializing a tuple. Initialize the tuple team names with this. Copy. In this order. No, okay. Sample up. Okay, so you just go parentheses, paste, end parentheses, and let's just get rid of the and here. And if we run this, oh look, it works. So this is how you define a tuple. And when you print, you can refer to each element by its index, just like this. Or when you can print out the whole thing, it's going to print out the whole thing in parentheses. Okay, you can have named tuples, and this is how you do that. First of all, you have to bring in this import this collections from a thing called named tuple because it's a new thing you're using here. It's a package. And so a named tuple allows the programmer to define a new simple data type that consists of named attributes. So for example, let's say you have a car named tuple. You have a named tuple, and it's a car type, and each tuple contains a make, a model, a price, a horsepower, and a number of seats. And so first you say this, and then it's like you've defined a new type. And the new type is designated by car. It's a tuple. And so you can define, and so this is like it's kind of like a class. You're defining this new um, this is the variable, and this is this is the definition of the variable, and this defines the variable type. So this variable type actually has like 5 elements in it. It has a make, and it's got a model, it's got a price, a horsepower, and number of seats, and and that type is called a car, and so we're going to define a Chevy Blazer as defined with these arguments, and then we're going to also define a Chevy Impala like that. And when we print them out, it prints out like this, where it prints out it's a car tuple, and these are the values, the element values here. So this is saying you can always still do this. Chevy Blazer, what's the second? What's number two? Would be 012. So the Chevy Blazer of 2 is the price, but you can also refer to it, reference it this way. So here you say house is named tuple. Create a new named tuple dog that has the attributes name, breed, and color. So I'm going to say dog is equal to named tuple of dog. Gotta put that in quotes, comma, square bracket, paste, end square bracket. And, oh, gosh, I gotta put some quotes in here, I think. Let's quote there, and quote there. I think. Um, there we go. All right. Let address equals be a named tuple that's got a street, a city, and a country. Create a new address object, house, which has got this. So I guess you'd say house equals address of this is that how you do it? Yeah. That, comma, this, comma, this. Does this work? Yeah, pretty good. Okay. All right. Oh, a challenge activity. Is this done already? Oh, it's done already. How do I start it over again? Oh, it's not done. Okay, great, good. Okay. Huh? Oh, all right. Define a named tuple called player that describes an athlete on a sports team. Name, number, position, and team. Okay. Player is a named tuple, and it's called player, and it contains name, number, position, and team. Okay. All right. Very good. Okay, what's next? Set basics. 356. All right. We are recording. Okay, so by the way, I've got my I've got the chat thing up here. I'm curious about my sound. I'm having trouble with microphones, and I think it might have to do with I've got wind blowing and fans, and I got a air purifier down here. So um, if the sound ever goes kind of flaky, just type something in the chat, and even if I don't see it right away, I'm going to know that there was something, and I can experiment around with some other microphones around here. So anyway, all right, set basics. Okay, now we're going to do sets. And so a set is an unordered collection of unique elements. So sets are unordered. Um, uh, Tuples are ordered. Tuples in this context are ordered. There are contexts where tuples are not ordered, but that's different. But anyway, sets are unordered. Tuples are ordered. Sets are unordered. And it's a collection of unique elements. That means that there's no duplicates. That's another nice thing about sets. Another interesting, useful thing about sets. So the elements are unordered and they are unique. They don't. So that if they're unordered, they don't have a position. They don't have an index. And if they're unique, it means no elements share the same value. And all that means is that if you have a set that's got a value in it, and you try to put in another one of the same value, it doesn't do anything. It just doesn't. It doesn't say it's an error or anything. It just doesn't add another one to it. It's like, oh, it's already here. So anyway, you can create a set using the set function like this, and so it's used the function set, and inside here is this list. And then you can also create a literal here. So this is a literal. And for this function, of course, this can be a variable. But this is like a literal. So here's, for example, we've got these names here. And when you print out the names, it looks like that. So we've defined a list, and it's got these names in it. And see, it's got Ron twice. Well, I didn't know you don't see that very easily, do you? What happens if I do this? No, it still doesn't. That's no good. Anyway, there's 3 Rons in there. Look at that. Oh my. 2 Harrys. Okay, so anyway, the point is you only end up with one of each of those. What is the result of this? Well, it's a set containing that and that. Yeah. Okay, what is the result of this? I think it's an error because this is not a list. This is just like 3 arguments. Set only takes 1 argument. List argument. Okay, so it's invalid syntax. All right. What's the result of this? Well, there's 1 100, there's 1 200, and there's 1 300. So these are redundant. So it's this. All right, modifying sets. You can add something to a set, just pops it in there. You can remove something and you say what it is. Here you add something, you say what it is. And pop just removes a random element. Random element. Now what's that used for? Why is number 2 an error? Because this is talking about this one, right? Um, that's not how you define a set. Uh, it's not this because set creates a new set, not a list. This is a list, and that's not this because this set requires an iterable object like a list to be provided. Iterable. That means it's a sequence. You can iterate through it. It's got a thing with elements, and you can actually it's got an order, and you can iterate through it. And these concepts, it's kind of interesting that that we're teaching these concepts as iterable and lists and sets and so on, and we're just teaching these to you as concepts now, and then later on when you actually start doing stuff, when you actually start writing code for applications, you see where all this comes into play, and it's kind of too bad. When I learned programming, I started I went to college in the 1970s, and we wrote programs that had all of these features in them before we had names for them. So it's kind of like and the way things usually work out is we write a bunch of programs and we have these things where we've got these things that are lists and they're iterable. You can iterate through them, and there's order and other things that don't have order, and they become important concepts when we're writing our programs. And then the mathematicians or the scientists, whoever, come along and they want to write books about it and they want to generalize it. So then they come up with these terms. Well, these terms have always been around, but they have a new application now, and so you're being forced to learn all these concepts before you can even visualize them. So it's kind of too bad, but anyway, so this this set function here, it's the set function accepts a sequence type object. It's a single thing that it accepts. So this is a single thing, and it's a list. You recognize this thing as the way you define a list. Up higher, up in a couple of sections before. Yes, the brackets do define a list. Very good. So this defines a list. So in fact here we define the list first. Let's take out. It's confusing. I'll get rid of these. Okay, so we got this plain old list here. I guess we can add Ron again. So we have this list, and a list can have duplicate elements. This list has got 2 Rons in it. Ron is the 0, 1, index 1, and Ron is also at index 3. Well, so we take this iterable list, and here we're going to create a set out of it. And the name of the set is going to be this names set. And so now when we print names set, it looks like, let me run this. It looks like this. It's got these curly braces here. It's got these 3 elements in single quotes, no duplicates. One of the Rons got bumped, and so we could have just taken this and put this here. And in fact, I'm going to add Joe to prove it. And so now when I run this, we're getting this here because of this, and this means nothing. This doesn't even do anything because really name set is this, and this time we, instead of using the variable list, we actually put the list itself there, and that's why this printed this. So good question. So here we're checking out the add, update, remove, and clear. Got these lists, and we can add to name one. We use this add method. So we have rider, and we're going to add it to the set names. We just say names dot add parentheses rider, and so that adds. You know, that's we have names one here, and it's got Pedro, Con, and Dean, and we do this add this name, and that gets added to names one. So now we got Hyungu added, and um, here we're adding a whole list, and so we don't use the word add, we use the word update, and so this is a list, names two, it's this list, and we're going to add that list to this list. We're going to, another term for it would be concatenate. And so now names one contains everything here, plus everything here, plus Hyungu. So that's everybody here, see? And then we're going to remove Dean. Oh, Dean, okay, Dean was removed, so that's why we don't see Dean over here. And then we're going to clear out names two, and so that's why names two is now empty. Oh, let's run this thing. Executes that. Now we're going to add that. Now we're going to execute that, and everything gets added. And then we remove Dean. There goes Dean. And then we clear out names too. Wow, that's amazing. And I got points for that. So that's how you get points for participation. You just click these things. Close your eyes and just click. All right, add all the elements of set goblins to set monsters. So monsters, update, goblins. Very good. Remove all of the elements from the trolls list. So it's clear, Trolls, clear. I think. I'm thinking, yes. Get the number of elements in the set. Is it size or len or len? Len. Len L's. Oh, a challenge activity. It's 409. Okay, great. Knocking off these challenge activities. Okay, we have got this thing here. Names. Got some names. Okay. We've got the three most popular male names of 2017. They were Oliver, Declan, and Henry. No way. All right, anyway, so write a program that modifies the male names set by removing a name and adding a different name. The sample output with inputs Oliver. Okay, so we're going to add Oliver. Right, removing a name and adding a name. Okay, so we're going to remove Oliver and add Atlas. So we started with this, which is precisely this. And then we're going to input a name to remove, and then we're going to input a name to add. And we're supposed to, actually do these functions. Okay, so I'm going to do, let's see, male names dot remove, parentheses, name to remove. And then I'm going to male names add name to add. See if that works. Very good, Declan. Okay. Okay, now we're getting into some more set stuff. These are some nice functions that you can do with sets that you can't normally do with lists. They don't make as much sense with lists and other things. We haven't learned about dictionaries yet. But. Okay, so we got this intersection. So we take a set, some set, and there's this intersection method, and the intersection method takes a list of sets as arguments, and the result is the intersection of all the sets. And we know what intersection is. It's the elements that are in common with all the sets. So that gives you back a set, and it's a set that might be empty, but it's a set that's got all of the elements, contains all the elements that are in common with all the sets, including the original set. Union takes the union of all the sets. So the set union has got, it's a set that contains all the elements that you see in any of these sets. No duplicates, though. So difference means you're going to take this set and you're going to return the elements of this set that are not found in any of these other sets. So in other words, it's kind of like you're subtracting out all the elements of this set, and then you're subtracting out all the elements of this set, and then subtracting out all the elements of this set. And so the result is going to be a set that doesn't have any of these, because they would have been subtracted out. So what's left over is what wasn't in any of them. And of course, if you try to subtract an element, let's say set B has got some element that's not even in this set, well, it doesn't matter. It doesn't cause an error or anything. It just doesn't end up subtracting anything out because it's not there. All right, the asymmetric difference is returns a set containing only elements that appear in exactly one of the sets. So it's kind of like it's okay. So it's like everything that's left from an intersection. Okay, so it's like you take the union. Is this right? Yeah. You take the union, and then you subtract out the intersection, and that would give you the asymmetric difference. No, maybe that's not quite right. Well, you know what it is. It's the it's you take the union, and of all the elements that are in the union, you find those elements that only appear in one of the sets, and that element will remain in the final result. So here we're only using two sets. So it's the elements that appear in either this one or this one, but not both. All right. So let's go down, and there's a nice challenge activity on that, I think. Oh, here we go. Okay. So let's do some of these participation things first to kind of get us warmed up. Okay, so we got these monsters here. We got some trolls. We got some horde. Fill in the code to complete the line that would produce the given set. Okay, so we got a set here. We start out with these sets. So this is a nice puzzle thing. So we've got Gorgon, we got Medusa, we've got it's monsters, something with trolls. Okay, so monsters, I bet it's union. So there's Gorgon, there's Medusa, there's William, there's Bert, and there's Tom. So it must be union. So you take monsters and you union trolls and you get this set. Yeah, correct. Okay, here you're using monsters with something and with horde. So it's this one with this one, and we only end up with Gorgon. Ah, look, Gorgon is in both of them. So this must be intersection. Okay. Now we've got asymmetric difference, monsters with asymmetric difference. Okay, so that means that these have to appear in only one of either monsters or something else. So Medusa, okay, so let's try monsters and trolls. So monsters and trolls would end up with all of them because all of the elements are only in one. So trolls can't be the answer. Well, it must be horde then. But let's prove that. So, oh wait, it can't be horde either. Monsters and horde. Oh, okay, Olga. Gorgon appears in both monsters and hordes, so it can't include that one. Medusa only appears in monsters, so that can be there. Bert only appears in horde. Okay, we aren't looking at trolls. Okay, we're only looking at monsters and horde. We're only looking at monsters. Oh yeah, and horde because that's what we're testing. And Tom is only in horde, so this would be the answer. Check. Very good. Okay. Oh, here's a challenge activity. This might be a good place to stop after this challenge activity, and then we're going to stick with this chapter. Uh, we're going to do more of the chapter on Thursday. We aren't going to do the uh, programming exercises at the end. We'll wait probably next week, or maybe Thursday of next week, because this is an important chapter. The concepts in this chapter are really important. And the first thing you do when you learn a new language is you go into these things. These the way they implement sets, the way they implement strings, the way they implement lists, all that, and you see what the new language, how the new language handles that, and you'll learn that Python really has a lot of functionality that that you don't see in other languages. All right, so we have a set. The following includes fictional sets of the top 10 and female. Okay, write a program that creates all the names that contain all of the top male and all the top female names. A program that contains the set of neutral names. In other words, those would be names that would be found in both of these. And then specific names that contain only gender specific names. All right. Sure, there's a lot of gender stuff in here. Okay, so this is all names. Now, what are we supposed to do? Note that sets are unordered. They are printed using the sorted function here. Okay, so they sort it. They sort it so that way it's easy to see if the two lists are the same. Otherwise, it'd be difficult. All right, so first of all, we make all names, and that would be the union, yeah? So all names equals male names um, union female names. Okay, so that should get all names. And I'm going to do this. I'm going to do paste, and I'm going to put neutral names here just because I want to run this and make sure I got all names correct. And I don't have these yet, but I'm just going to put that there. I know those are wrong, but I want to see if my all names is correct to see if this works. See if it lets me run. Okay, test. Okay, all names works. It does. Aiden Bailey. Nice alphabetically, so all names works. These other two ones don't work. Obviously, I knew they wouldn't work, but at least I got the all names correct. All right, so neutral names would be the ones that are in both intersection, and specific names would be ones that would be not in either, and this would be this fancy asymmetric. What is it called? Asymmetric. Oh, asymmetric difference. Copy. asymmetric difference. Paste. All right, let's see if this works. What do you know? All right, let's see. So it's 421. Okay, we don't. Why don't we end now? We could end now. But dictionaries are the last cool things, and you see that with dictionaries, they're kind of like sets, except for they have. It's kind of like the indexes have names. It's like so we have these things called prices, and index 0 is this, index 1 is this, and index 2 is this. But we actually have instead of indexing them by an integer, an index, we have they have names associated with them. So that way, we can refer to prices like this. The prices of pears is 179, which is how do we add it? It's this one. So anyway, we will is when we read the Python code, how do we separate a tuple, dictionaries, or lists? Uh, Well, you need to pay attention of well, dictionaries will have these two kind of parameters here, and they look kind of like sets just because they have the curly braces, but sets are just numbers. So you get to be good at it um, by what the characters are used to define it, but also the context. The it, it'll be pretty obvious from the context and the way the question is worded whether it's a set, and you're gonna get to know them not by set or tuple, but you'll just know that you need to do this kind of data structure. This is a list because we have an ordered list of numbers, or we want to sort them. Okay, that's a list. Or here we have names of a student with midterm score and final score. So that would imply a dictionary sort of setup, and so it'll become obvious after a while. And the way that happens is we just practice. And this textbook is a good textbook because they've done studies and they found that doing a bunch of smaller problems, doing a bunch of less complicated problems like we are, these little participation activities are great because they're just simple things. You answer the dumb little questions, but then that's enough practice for you to actually go in and do the challenge activities, which are a little bit harder. And then presumably at the end, the programming exercises should be good. And they have so some of these programming exercises at the end. There's like short ones and long ones, and they tell you that many short ones, are better for your learning, and they're easier too. You don't stress about them as much, uh, but they still have the long ones because a lot of instructors they prefer the long ones just because they're used to the long ones. It's easier to grade one long one than it is to grade five short ones, but here we've got this auto grading, so it sort of makes it easier on us because we've got this thing to assist in the grading, and then that way we can go to something that's better for learning. And this, the repetition of the short questions and reinforcing, a bunch of the same types of questions. It turns out with these things, if you hit refresh, some of these challenge activities, hit refresh, it's a different problem. There's some of them are that way, but they want to eventually have all the challenge activities. If you don't do it right, you come back again, and it's a slightly different problem, and that helps you learn better. So, are there any questions? Any more questions? All right. I mentioned to somebody in a different class, I think, but if I'm gonna touch on almost everything in these lectures to for the assignments, the assignments that you get points on. And so I'd like you to work on the problems before the answers appear in a video. However, if after working on them you're stuck and you end up waiting until the answer appears in the video and then you do it then, and then you submit it then, that's just fine. Okay, I'd say, well, whatever works, and it's the repetition of getting them, wrong, corrected, and then right, and then that's when you get your points. That's what's going to reinforce this. All right, it's 427. Got a new backdrop here. All right, so I will see you next Thursday.
Thank you.
Yep. Thank you.